Hello everyone, welcome to today's video. In today's video, we'll be discussing about alkanes, alkenes and alkynes, the reactions that is there in the syllabus. So let us begin the video directly. The first topic we are coming to is alkanes, and under that is the first topic, methane preparation, direct methane preparation. So for methane preparation, we will need is sodium ethanoate, as written over here you can see, sodium ethanoate. So we will need sodium ethanoate, CH3CONA, written over here. Fine. With that we will need soda lime. Soda lime is NaOH plus CaO. NaOH plus CaO will give you soda lime. Now why are we taking a mixture of both and not one? Because they're deliquescent. So in to prevent that we are taking this. Clear? CaO alone cannot do, and NaOH alone can do, but it will be deliquescent. So it is not our motto. So we have combined them to soda lime. Clear? Understood? So this plus soda lime, that is this two, at 300 degrees Celsius will give you sodium carbonate plus methane gas. Clear? Is sodium carbonate plus methane gas. So you have to remember the reaction, not memorize the reaction. Okay? You have to remember the reaction, not memorize the reaction. Okay, CH3CONA plus NaOH forms Na2CO3 plus CH4. Clear? This gas is collected by downward displacement of water because it is slightly soluble in water and it is also lighter than air. Clear? Understood? So this is the reaction that you need to remember in case of methane preparation. Clear? Now the next preparation is ethane. Methane done, now ethane comes. Clear? For ethane, we will be not using ethanoate, we will be using propanoate. Clear? Propanoate. What changes will happen? Changes happen will be and balancing changes obviously. Clear? Understood? Balancing I have not done. You have to do the balancing. Okay? Okay. If needed. Obviously if needed. Okay, understood? Yes, not needed also. Okay. So this is sodium propanoate, this person reacting same reaction. This is also remaining same. Changes happening only in this case. Change is only happening in here and here. Rest all are same. So this is preparation of ethane from sodium propanoate. Methane from sodium ethanoate. Now after this also, if you are forgetting how to remember this reaction, right? How to remember? Then the shortest way to remember is if you substitute this particular thing with R and just assume it like this, because rest part will remain same, but you have to memorize certain parts. Done. Okay. What did I write? I wrote RCONA plus NaOH, CaO, Na2CO3 plus RH. Now whatever be the R value, we will put that value just. Okay. See the example first. I am writing in little bit smaller here. RCOONA plus NaOH, CaO, RH plus Na2CO3. Okay. R is alkyl group. Clear? R is alkyl group. Now here instead of R I am putting CH3. So CH3CONA plus NaOH in presence of CaO. R, that is CH3H. This is a very bad way of writing. So instead of CH3H we can write CH4 plus Na2CO. Done. Got the reaction. So if you cannot remember individual reaction, remember this part. But if it is asked directly, then you cannot write both the reactions. Write either of the reactions is necessary, suitable for that question. Okay. So this is methane preparation. Now for ethane preparation, instead of R you will put ethyl. So this becomes this plus NaOH presence of CaO. Now here C2H5H This is again very bad way of writing. So instead of that we will write good. So here what we have written is R. R always stands for alkyl group in organic chemistry. Organic chemistry R is always alkyl group. So I have substituted the main part R as C2H5 and CH2 in two reactions, and the reaction comes out. Clear? So if you are having problem in memorizing individual reaction, you can go for this. Clear? So this is one of the process. Other all processes I have to read. So this was laboratory preparation of methane and ethane. Next we are coming to other methods. Okay. Three other methods we are going to read. Not very much. Three reactions only. Three more reactions we are going to read. That will be applicable to both. Few will also not be applicable. Anyways, and the first one is iodomethane or bromomethane, that is dependent. Okay, iodomethane or bromomethane, both. Clear? Can be, because they all are halogens, right? So both. Clear? So it's iodomethane, bromomethane. First let's do with iodomethane, then let us do CH3I plus, this is reducing agent. Okay, here there will be a reducing agent. Clear? It's not hydrogen, please. This is reducing agent. Clear? Reducing agent. We have placed hydrogen. It seems like nascent hydrogen. You can take it as nascent hydrogen, but this is basically reducing agent. Clear? So here what will happen is this person will replace this person from here. Clear? So it will become CH4 plus 1H is remaining over here, HI. Clear? It's basically two nascent hydrogen from one hydrogen molecule only. Different case. Okay. Okay. So this two nascent hydrogen, it will give you this respective gas that will be evolved out, and this is your compound. Now instead of this, leave it. Bromomethane. Bromoethane, not methane actually. Okay. Clear? Bromoethane. Written? Here it is C2H5 Br plus 2 nascent hydrogen. What will it give? This Br will get replaced, so it will be C2H6 plus HBr. Okay, the thing you need to remember in this case is, that is, this particular halide has to combine with one hydrogen and give us one thing as a product. Clear? And another hydrogen will be getting inside this. Moment if you remember this formula for ethane, it will be easier, right? C2H5 is not the formula for ethane. One hydrogen has to be added. So one from here it will add over here, written there. Where will the other go? It will combine with this Br because it has been thrown out from there. Substitution reaction is occurring. Right? Understood? So some logics you have to apply. Some logics can be applied from over here also. Understood or not understood? Clear? Okay. Okay. Now see, if I write Rx plus twice hydrogen forms RH plus HX. Will it work? Do you think? Let's see. I am putting CH3. I am putting in place of it. What is X? X is halides. Clear? X is halides. Haloalkanes. Okay. Plus 2H. H is H only. Okay. Do not change that. So CH3H. Again very awkward looking, right? So instead of CH3H we will put CH4. CH4. Plus what is H? H is H. What is X? I. So HI. Clear? This was the required product. Right or wrong? This was the required product last time. So see, you have got the answer. Now instead of this, if we put C2H5, then we will get C2H5I plus 2H gives you C2H6 plus HI. Clear? So this will not work over here. let's keep it Br only. Clear? So instead of this, we will get HBr. Understood? Clear? So the basic formula is that. If you can remember the basic formula, then also it's okay. You can remember the individual reaction, it's fine. Okay, basic formula is this, apply this, we'll get these reactions. Clear? Understood? So this was iodobromo and iodomethane and bromoethane. Clear? Next reaction that you have to memorize. Again memorize, okay? But, just memorize the reaction randomly. Clear? Okay, next reaction is Al4C3. This is Al4C3, aluminum carbide. Understood? Aluminum carbide. Reaction with water. This person will give you ALOH whole 3. Now see, this person going with this to give this. C hydrogen gone, 100 remains. CH, that nothing, CH4 also has to be released. This will release CH4 gas. Clear? Understood? Balance the reaction. Okay, balance the reaction. Little bit big balance will happen, that I also know. 4Al needs to be balanced. Now 4O is there. No, not 4O. 3. 12O is there. And how many? 12 hydrogen is there. 12 hydrogen. 24 hydrogen is there. I put 12 over there. 3 4 is 12 and 12. 12, 4, 3, 4, 3. I put 3, carbon will be balanced if I put 3 carbon. So this will become 12, this becomes 12. Done. Clear? Okay, done. So this is aluminum carbide. Clear? So when water is added to room temperature to aluminum carbide, methane gas is produced. Understood or not understood? Understood or not understood? Okay, next. Next is a very important thing coming up. A very important thing coming up there in class 11 also. Woods reaction. Next is a very important reaction. Woods reaction. Understand Woods reaction? Woods reaction says that in presence of dry ether, if you heat iodides, methyl iodides, you will get ethane. Clear? You will get ethane, not methane. Ethane. Methane cannot be produced. I will give you the reason. First, let's understand. Rx is there plus Na is there. This is 2Na. This is 2Rx. Clear? In presence of, very important, must mention, dry ether. Ether, you already know what is ether. It's dry ether. In presence of dry ether, it will give you RR plus NaX. Basic syntax I have given. Okay, basic syntax I have given. Rx plus 2Na, both 2. Dry ether, RR plus NaX. Clear? Now apply. How will you apply? Suppose I am putting 2CH3. Instead of X, I am putting I plus 2Na in presence of dry ether. RR I have to put, so it will be CH3 plus NaI. Done. That's Woods reaction. That's not only one reaction, a lot of reactions are there. Clear? So, this CH3, if it seems very awkward to you, write it as C2H6, no problem, that is ethane only. So, this part is ethane. Did we get ethane? Yes. But now your question might be, we cannot prepare methane by this method. Why? Why? See, methane has only one carbon. Methane has only one carbon, but we cannot get a single carbon over here. You check it, you cannot get. How will you get? No way of getting. You cannot make propane from here. You cannot make pentane from here. All even number you can make. Odd number of carbon atom is not possible only. Clear? This method, this Woods reaction is not applicable for organic compounds or other alkanes with odd number of carbon atoms. Why? See, because here twice is there. So suppose here C3 was there. So this will C3. This will come over here. 3 plus 3 will become an even number. Right? So there is no scope of odd numbers. All have to be an even number. Clear? Understood? Clear? The very important reaction. Methane cannot be prepared from Wood's reaction. Only preparation is ethane. Clear? Many other are there, it's not there in the syllabus. Okay? Next one we are moving on to is substitution reaction. Next one we are moving on to substitution reaction. See, substitution reaction, as I have already told, its tummy is already filled up. It will not eat anything more. It will substitute what it has eaten, right? I have told you in the beginning, right? So now see, suppose there is C2H6 and I add Cl2 to it. The final product that I will get is C2Cl6 plus HCl. This is the final product I will get. When I add C2H6 plus Cl2, the final product I will get is C2Cl6 plus HCl. How and why? Step by step, when you find C2H6, I am just showing one step, okay? I will not show every individual step. What will happen? First step, 2 hydrogen cannot be replaced at once, okay? This part. Clear? So now this hydrogen is here, this chlorine is here. What does it form? HCl. That gets out. What is this forming? CH5Cl, C2H5Cl. First step. Again after this step, chlorine is already here. This hydrogen will now replace with another chlorine over here. Another chlorine gone, another hydrogen came here. Another hydrogen chloride is there. Like this reaction will proceed. Clear? Understood? So all these hydrogens will gradually get occupied by chlorine. So first step will be one hydrogen will go away, carbon number will not change, be careful. So this is CH5Cl plus HCl. Next step will be C2H5Cl plus Cl2 will give you C2H4Cl2 plus HCl. So do you see, every step one hydrogen is getting replaced, instead of that chlorine is entering. That is what I want to mean, okay? Another step, let us write C2H4Cl2 plus Cl2, it will give you C2H3Cl3 plus HCl, okay? What do you find? Every turn hydrogen is increasing, chlorine is increasing, hydrogen is decreasing, right? So next step what will it be? C2H2Cl4. Last step it will be CHCl5. Last step, second last step it will be C2H8Cl5 plus Cl2. Last step now coming, and it will give you C2Cl6 plus H. That is what I already told you before. Correct? This was the second last product. This is the last final product. That is C2Cl6. All hydrogen have been replaced by chlorine. Clear? This is substitution reaction. Clear? This is hexachloroethane. So what is happening? Generally, all hydrogens are getting replaced by chlorine. Substitution reaction is occurring. Clear? Understood? These reactions are only there in your syllabus. Other reactions are not there. Okay. The last part that I need to discuss from alkanes is oxidation. Little bit portion of oxidation. So whenever any organic compound is heated, you already know that whenever any organic compound is heated, it gives rise to CO2 plus H2O, be it methane, be it ethane. Both will give rise to this. Correct? But this is when normally you are heating normal, everything is normal is fine. This is the product. If something you make abnormal, what is something you make abnormal? That is, you decrease the supply of air, you decrease the supply of oxygen, then some different products can be formed. First case is the air supply lowered. Clear? First is air supply lowered. Then in that case, CH4 when reacting with O2, instead of this person it will give this person. You already know that. Insufficient incomplete combustion that gives rise to monoxide. Correct? Ethane will also give you the same. Next, when O2 concentration you down it, O2 concentration is down, then CH4 reacting with O2 will not give you any carbon oxide but direct carbon, that is soot. Clear? Along with that H2O. Clear? This is soot. Clear? These are the three conditions that you need to remember for oxidation. First condition is you have lowered the concentration of air, that is carbon monoxide will be produced. Second is you have lowered the concentration of oxygen, that is carbon soot will be produced. Clear? Understood? This is all the reaction that you are having from alkanes. Next we move on to alkene. Okay, in alkene we will be reading about the first member, ethylene, that you have read in biology also, that it is the only plant hormone that is present in gaseous form, right? Yes, that is present in gaseous form and is responsible for ripening of fruits. Okay, ethene preparation. We are bothered with preparation. Preparation of ethene is done by two steps. Preparation of ethene is done by two steps. First step is dehydration of ethyl alcohol. Another step is dehydrohalogenation. That is coming. First, let us understand dehydration of ethyl alcohol. Okay, dehydration. Water removed. Correct. Water removed from this main substance. Basically, ethyl alcohol is C2H5OH. When this person, C2H5OH is ethyl alcohol, accepted. When this person is heated at 170 degrees Celsius in presence of concentrated sulfuric acid, then this person gives rise to C2H4 plus water. Understood or not understood? When this person is heated at 170 degrees Celsius, this person will give rise to this. Okay, understood? Clear? Now in your book directly it's not given, it's given in a different way. Not actually very different way. It's given like CH3CH2OH plus H2SO4 will give you hydrogen sulfate plus water, and in the another step it will give you ethene. You cut the both reaction, you will get this reaction only. End up getting this reaction only. No problem is there. See, CH3 CH2 OH added with H2SO4. This is given in the first step. It gives you CH3 CH2. This was this person only. Different. Anything different? We have just expanded that part. Nothing else. C2H4 we have expanded. Nothing different. Okay. HSO4 plus H2. Okay. And next step they have got is CH3 CH2 HSO4. That 100. This is same condition over here. Okay. I am not writing same condition. Okay. This gives you CH2 double bonded with CH2 plus H2O. Oh, sorry, not H2. Here to H2, SO4 is here. H2SO4. Now say, can you get back to this reaction from me? Yes, why not? See, this C2H2 has no complements, it will be stayed back. Done. H2SO4 is here and here. This cancels out. Done. H2SO4 not there in the reaction. Over here only it is there. This catalyst. Okay. Next this person and this person will get out. So this person remains. What has remained? That is the answer. Check properly. This person remains, this person remains, this person and nothing else. So this person and this person remains from this side, and this person only this from here we are getting back to here. Clear? So it's written in an expanded way, nothing else. Same reaction I have written also. This is written in an expanded way. Directly you can sum up in this reaction only. One reaction summed up everything. Clear? Just first step, added H2SO4, got hydrogen sulfate. Then we have got we have again this heated at 170 degrees Celsius with concentrated sulfuric acid, and we have got back this. Clear? Understood? This was actually excess. Clear? Excess of H2SO4, right? That's fine. So main reaction is this. So to produce ethene, this thing is needed. That is dehydration of ethyl alcohol. Main thing is dehydration. Here also dehydration, here also dehydration, same thing. Clear? So first step understood, dehydration of ethyl alcohol. Reaction C2H5OH 170 degrees Celsius, concentrated sulfuric acid gives you ethyne and water. Next comes dehydrohalogenation. By the term only you can understand that it's removing the halogens. Correct? It's removing your halogens. One reaction only I will show. C2H5Br. Reaction occurs in KOH alcoholic medium. Okay, KOH alcoholic medium. That is hot and concentrated. Clear? Understood? Hot and concentrated KOH alcoholic medium. Upon reaction, it will give you C2H4, more prominently written as CH2, double bonded CH2. That's nothing but C2H4 only. Clear? Plus KBr plus water. Clear? Substitute this with I, substitute this with F, this will change, this will remain same, this will also remain same. Only this part going to change, whatever you write over here. Clear? Understood? So this is dehydrohalogenation reaction. Understood? Here you write I, this will become Ki. You write here F, this will become Kf. Clear? You write here Cl, this will become KCl. Okay? Understood? Okay. This gas is collected downward distribution of water. It's inflammable, okay, and it's insoluble in water. Same thing as before. So understood. So the first step was first way of preparation was dehydration of ethyl alcohol C2H5OH, presence of 170 degrees Celsius sulfuric acid concentrated. We are getting ethene plus water. This step is dehydrohalogenation step, where we are writing C2H5Br, C2H5Cl, C2H5F, C2H5I, halogens I'm talking about. That in presence of hot and concentrated KOH alcoholic medium, it gives you ethene plus respective salt, that is KCl, KBr or Kf, okay, and Ki, and plus water. Clear? Understood? This is dehydrohalogenation reaction. Clear? Okay. From this part you are having only this much. Yes, right. Next we are moving on to the last part, alkyne. Okay. Next we are moving on to alkyne. In alkyne we have your preparation of alkyne. Preparation of alkyne only we have, and that is also from two things. First thing is your calcium carbide. Clear? From calcium carbide, how will you prepare an alkyne? That alkyne is also ethine. Okay, that's ethylene. Not ethylene, it's ethyne. Don't say ethylene. Ethylene is so different. Ethene. Okay. So whenever you heat this, CaCO3 plus H2O, this will give you CaOH whole. Remember, we have done one Al4C3. That one, that type. Okay. So this will remain with C2H2. One out. This is ethyne. This is what we wanted. So this is the first step. From calcium carbide, if you want to prepare, you have to write this reaction. Understood? Understood or not understood? Then next step preparation is preparation from 1,2 dibromoethane or ethylene dibromide. Clear? 1,2 dibromoethane. Preparation from 1,2 dibromoethane. Okay. Now how will you prepare that? Reaction remains more or less same. Reaction remains more or less same. Like C2H5Br, KOH, alcoholic medium, hot and concentrated. Hot and concentrated was right. Then what's the problem? Here small change will be there. This. Clear? What we have done? C2H4. It's what? Ethane. Ethane is, we are going to use C2H4. Okay? Under video you will understand. Okay? So we have used this percent. So remaining percent form will be this percent plus respective salt percent plus water. Understood? Clear? Balance the reaction and not balance it. So it's C2H4Br. This can be written as like this also, as written in your book also. It's written like this: C2H2Br not C2, CH2Br like CH2Br. Clear? This is written like this. Fine, you can write like this, no problem is there. You add up both, so C2H4Br will be the answer. C2H4Br2 rather I will say. C2H4Br2 will be the answer. So here 2K will come up, okay. So C2H2Br2 will be here, and here CH will remain out. KBr will be there, H2 will be there. This is preparation from 1,2 bromoethane. Clear? C2H4Br plus 2KOH in case alcoholic medium. This temperature is maintained at 200 degrees Celsius. Okay, just remember it. 170 degrees Celsius in case of previous one. This is 200 degrees Celsius. Okay, 200 degrees Celsius. This temperature is maintained, and we get the product as this percent ethene. This C2H2. C2H2 is ethene. Clear? Understood? So this was all that you need to read from the chapter organic chemistry. Not very hard. Whatever is there in the syllabus I am talking about. It is not very hard. So to read the reactions properly, especially important is Wood's reaction, very important reaction, and preparations are obviously important. Study of compounds preparations are there, and here preparation from the 3 compounds are there. It is very much necessary. Okay, so that was all in this video. See you in the next video. Thank you.